Vernier now offers two choices in dissolved oxygen probes, a slightly less expensive one called the Vernier Dissolved Oxygen Probe, and a slightly more expensive one called the Optical Dissolved Oxygen Probe, which is virtually plug and play. The one I'm going to show you today, the Vernier Dissolved Oxygen Probe, requires a little more setup and calibration, so I'm going to teach you how to do that today. So here's the probe, and I'm going to start with putting my goggles on. First thing you need to do is add the DO electrode filling solution. So I'll take off my blue cap here, which you want to take off but save for when you store it later. It's a protective cap. And then at the end is a cap that unscrews, and that's where we're going to put our DO filling solution. The filling solution comes with the box that it's sold in, and a little pipette comes as well. You're going to put 1 milliliter of the filling solution in. And if you ever don't have this pipette available, you don't really need it, because all you're going to do is put in enough filling solution so that it goes to the bottom of the little threads inside the cap. We want it to be overflowing. So when you put the cap back on the probe, what we're looking for is a little bit of overflow. 1 or 2 drops is all you need, but a little bit. And there they go. Perfect. And I'll rinse that off. Okay, it's now ready to put in our water. It can go in any water at this point, because what we're going to be doing is just connecting it to our interface. In this case, a LabQuest 2. I plug it in, it auto-identifies, and we're going to leave it in this position for about 10 minutes to warm up. Okay, my 10-minute warm-up time is passed, and now I'm ready to calibrate. So on my LabQuest screen, I'm going to just tap anywhere in the red box and choose the Calibrate option. I'm going to calibrate now. So the idea here is that we're going to put it into 2 known environments, tell the LabQuest 2 what those known environments are, and then it will be calibrated and know how to measure our water. So the first known environment is going to be this sodium sulfite solution. This has no oxygen dissolved in it, so this will be a 0 dissolved oxygen point. So what I'm going to do is get this opened, take the probe out, rinse it off a little bit because that was our stream water. Dry that very gently on the sides with a paper towel. Now I want you to notice this live voltage being displayed here. It's probably going to be up over 2 volts at this point, but once I put it in the sodium sulfite, okay, and all you need to put in is the very tip in this case, watch what's happening to the voltage. It's dropping, and it's usually going to go down to between 0.2 and 0.4. That tells you things are working properly. If it doesn't, then you may need to replace that cap that we put on earlier. Those don't last forever. If you use this a fair amount of time, I think a lot of people replace it maybe once a semester. If you don't use it very often, maybe once a year, but they're not very expensive. So we give you 1 extra one in the box, but you may want to order some more when it's time. And this not going down to something like 0.37 like we're seeing here, that's perfect. If it's not doing that, consider getting a new cap. Okay, so we're stable here. So for value number 1, this is our 0 milligrams per liter. So I just type a 0 and say keep. And now it's asking me for my known value number 2. So let me rinse this off. Need to rinse this very well. You don't want any of that sodium sulfite solution still on there. Dry it. Okay, set this aside. Now, my second calibration point is going to be saturated water. But I can't get saturated water unless I bubble it with oxygen for a day or so. So instead of saturated water, what we do is we kind of fake it with water-saturated air. So this is how it's done. We put a little distilled water in the bottom of this bottle. We're going to place the probe in this bottle, and this bottle comes with the probe as well. We slide the bottle's cap onto the sensor, put it in here. So what we're doing is we're creating a humid environment, 100% humidity, with the probe right over the top of that water, but not touching the water. And we watch our voltage again. It's gone from 0.3 up to 2.4 something. It's still equilibrating there a little bit, but it's close. So we'll let it continue to equilibrate while we look up how many milligrams per liter that should be. It's 100% saturated, but that doesn't tell us the milligrams per liter. We find that in the booklet that comes with the probe. So I open up to that chart, and I find that at this pressure, which is 760 millimeters, I measured that before we started, and the temperature, which I know it is in the room, which is 21 degrees, we have exactly 9.00 for our milligrams per liter. So that's what I put here, 9.00. And keep that. All right, so we're back to the calibrate screen. Now we're going to do one more thing while we're here. And this is a feature of many probes that a lot of people don't know, so it's good to learn this. We have 5 tabs across the top of this screen. One of them is called storage. You tap on that tab and you get a button here that says save the calibration to the sensor. This will save what we just did so that the sensor is going to remember it. Whether we unplug it, move it to a different LabQuest, it will put it right on the sensor's electronics. So I'm going to tap that. It says I'm going to save the calibration. Good, that's what I want. So tap OK. And that's done. We can say OK again to get back to the main screen. So the calibration is done and the calibration is saved. I take it out of the bottle, and now I'm ready to actually take my measurement. So here's my water. If I put the sensor in and hold it still and watch my LabQuest screen, you're going to see the reading constantly drop. That's normal, and that's because right at the surface of the sensor, it is consuming a little bit of oxygen to make the measurement. So all I do, it's a negligible amount, so it doesn't matter as long as we are slowly stirring. And if we are slowly stirring and we watch the number on the LabQuest screen, it will eventually stabilize. Okay, so it looks like we have 8.1. That's our dissolved oxygen from my sample. If we wanted to collect some data, we could do that too. But oftentimes you just want to know the DO levels, and that's what it is. So the Vernier dissolved oxygen probe is not a difficult probe to use. It just requires more steps of preparation and calibration. If you've lost the booklet to find that dissolved saturated amount, you can download it for free on our website. You can also get it out of any of the Vernier books that use the dissolved oxygen probe. But for any other information on the Vernier dissolved oxygen probe, you can just go to our website, www.vernier.com.